A 2 kilograms of cookie stain is separated at the 3 meter per second square in the direction shown by the A bar. So the frictional force in the surface caused by the 3 forces in the force. So only F1 10 newton and F2 are 20 newtons are given. So we have to calculate the start force. So in this case, we can see the thing here. So this is the F2. F2, and this is acceleration at A at the 50 degree. And this is for the F1. F1 is 30 degree. So in this case, we can have to add the all force. So there's acceleration means there will be the net force, net acceleration. So net acceleration is you can calculate so the F net is equal to mass multiply A. So this is equation. So the mass is 2 kilograms. So this is 2 multiply A is acceleration. Acceleration is given. So acceleration 3 meter per second, so 3. But this acceleration is at 50 degree. So this is the 3 cos theta, cos 50. So this is what is the 6 cos 50. So this is net acceleration. Okay, so we can calculate. So this is F net is equal to this holding the all is a positive, and therefore the right hand side. So this is for the F3. We assume that the F3 is here. F3 is a positive plus minus F1. F1 cos 30. So this is a negative. Is equal to 6 cos 50. So that we can see the F3. F3 is a minus F1. F1 is a, we already know. F1 is a magnitude of 10 newton. F2 is a 20 newton. F3 does not include because of this is the perpendicular. Perpendicular F2 does not influence on the overall acceleration. So in this case, F1 is a 10. Cos 30 is a 0.866 equal to 6 cos 50. So from here you can get the F3. F3 is equal to 6 cos 50 plus 8.66. And you got the F3. So the next one is the gravitational force. So the I is the influence the any particle about the earth surface. So this is the gravitational force. So this is the earth. So this is the mass. So force minus a gravitational force. So the gravitational force that you can calculate, Fg is a gravitational force. It's equal to m into g. So it is m is a mass in a kilogram. G is a 9.8 meter per second square. So F equal to mg. So in this case, our gravitational force is a newton. Because the gravitational force, weight happen. So weight is the result of the gravitational force. So weight is caused by the gravitational force. Weight is caused by the gravitational force. So the gravitational force F is equal to the m multiplied by g. Two kinds of force we are balancing. So this is for the weight. So this one will be the m1 mass, and this is the m2 mass. So this force is the Fy is equal to m1 into g, and F2 is equal to the m2 into g. M1 F2 is a m1 into g. M1 is a m1 into g. F2 also m2 into g. So this is for the vertically down. So therefore, because of this one, we can assume that if F1 greater than F2, so F1 greater than F2, so we can calculate net force. Net force is equal to F1 minus F2. So this is a M1G minus M2G. Okay, so net force. Net force we can also calculate. So net force is a net mass multiply acceleration, net acceleration. Net mass multiply net acceleration. So net mass is this is a two particles are moving together, and therefore this is a n1 plus n2. And net acceleration is A. Is an, so this is a n1g minus n2g. So therefore you can calculate an. n1g minus n2g divided by n1 plus n2. So this is the way we can calculate the net acceleration. Net acceleration means the two weights are opposite. So that in this case f1 is greater than f2. So we can write down the equation. Net force is equal to f1 minus f2. So the net force is equal to net mass multiply net acceleration. So this is equal to the n1g minus n2g. So the net mass is that two particles are moving together. Therefore the n1 plus n2. Net acceleration is an. From equations we can calculate an is equal to n1g minus n2g divided by n1 plus n2. So that in the such case we can also see the thing. So this is for the plot is put on the table. So tables then we just 4. Therefore it's a Fg. And this is the reaction for the Fn. So when the table is stationary, this is Fn is equal to Fg. So Fn is equal to Fg. H stationary, Fn equal to Fg. And therefore we can write down the equation. This is for the Fn vertically, Fg is horizontally. So Fn equal to Fg. So our force equal to our force. For that situation. In the meantime, we also see the tension. Tension means that we are holding the block here. This is the weight. So this is mass, and this is the acceleration g. So this is the tower force is equal to the F is equal to m into g. This is equal to a tension T. So the tension T is equal to F is equal to mg. So this is the Newton. So our force and the tower force are equal. So the tension in the string is equal to the F is equal to mg. So this is the way we calculate. So the tension phenomena we can use on that kind of thing. This is the pulley here. We use the tension T. So this is T, this is the mass. So T is equal to, because the T is this block is a moving. So we can write down T is equal to the mass multiplied acceleration. So T is equal to m into A. So tension is equal to the n into A. So if the block is moving on the wall, all the this is the table and this is the desired mass multiplied acceleration equal to the tension. And similarly, this block. This block is a 4 by the pulley. So in this case, this block will just mass m here. So this is for the tension T. So tension T go up. So this one acceleration is the A. So T is equal to m into the g. So this is what acceleration. T equal to m into g. So this is the tension and the gravitational force. The weight must be equal to the tension. So this is the saturation of the tension force and the acceleration. So the areas of body above the earth, they are influenced by the gravitational force. The gravitational force can be calculated as G is equal to mass multiplied the gravitation. So two mass are balancing by the on the balancer. So in this case, you can see that N1 is the mg, m2 is the m2g. So the f1 is greater than f2, so you can calculate net force is the f1 minus f2. So that we can calculate the net mass multiplied net acceleration. So this we got as n1g minus m2g. So we can place an object in any situation. One thing is that we place the object on the table. So gravitational force equal to the normal force. Okay. So now our force equal to tower force. And when there's the object is pulled by the through the hand So in this case, the tension in the roof is equal to the mass multiplied its acceleration, gravitation. On the pulley, so in this case, tension T is equal to mass multiplied gravitation. So those are the situation of the tension, force, and acceleration. So this is the body. When we put the tension, so this body is the body weight is 75 Newton. So this is a 75 Newton. So tension T equal to or greater than or less than 75 Newton when the body is moving outward at the constant speed, at the increased speed, or at the decreasing speed. So in this case, at the constant speed, body is moving. So long as the body is moving, so tension is greater than the 75 Newton. So at the constant speed or at the increased speed, that also equal to the 75 Newton. But at the decreasing speed means that moving downward. Decrease when the moving downward, so in this case, tension T is less than the 75 Newton. So for the A, T greater than 75 Newton. B case, T still greater than 75 Newton. For the C, T less than 75 Newton. So this is the answer for this problem. On the inclined plane, so on the inclined plane, such as the angle theta is a 30 degree. So this is a chord. The chord is the force. The force is at T is at 25 Newton. So this is a T 25 Newton. So mass is at 5 kilonewton. So mass is pulled out. M is at 5 kilonewton. So this is T is at 25 Newton. So mass is 5 kilonewton. So normally this mass is affected by the gravitation. So the gravitational force caused by this mass is N F is equal to N into G. So directly, so this is a 5 into 9.8. 5 multiplied 9.8, so this is a gravitational force we can calculate. So this is a 5 multiplied 9.8 is a 5 multiplied 9.8, so that will be 49. So practically 49 that you can. Nice stop. Okay, so this situation that we can analyze as a force. This gravitational force we can divide it into the two components. One component is vertically downward, proportional to the one component is parallel to the plane, another component is perpendicular to the plane. So this to the mass you can divide it into one component. This one is parallel, so F8. And this is the perpendicular, so Fy. So Fy does not cause any moment because of this plane is a small plane. Small plane, so that there is no friction. No friction means Fy component cause a friction, especially this plane cause a friction here, mu here. In this case, this is a frictional force. Frictional force is equal to mu multiply Fy. Okay? But in this case, there is no frictional force. No frictional force we don't need to concern about the Fy. Only the Fa. Fa is pull down the plane downward to the flow. So tension T pull the plane outward to the flow. So this is the situation. So in this case, we have to calculate the net acceleration. Net acceleration we have to calculate. So this component we can calculate is the Fy is equal to this angle theta 30. So this one also 30 degrees. So this is the Fy is equal to n multiply sin 30. N sin 30. F is equal to n cos 30. So Fy is m cos 30 because this component here. F is m sin 30. Fy is m cos 30. So that we can calculate Fa n sin 30. So mass is we can calculate mass is equal to 5. And so mg sin 30 because of gravitation. So that's the mg sin 30. Mg sin 30. This is the mg cos 30. So mg sin 30 we calculate the mass is 5, gravitation is 9.8, and sin 30 is 0.5. So this is a 49 multiplied 0.5. So 49 multiplied 0.5, we calculate so 49 multiplied 0.5, so that will equal 24.5. So 24.5 Newton. So this one goes down this direction. And tension T is a 25 Newton per hour. And therefore the net force. So tension greater than the tower force, so the T minus FA. So the T is equal to 25, FA is at 24.5. So you got the 0.5 Newton. And as acceleration A can be calculated. So the net force divided by mass. So 0.5 Newton divided by mass is we already calculated that this is the 5 kilogram. Minus the 5 kilogram. So we got the base at 0.1 meter per second square. So acceleration is 0.1 meter per second square. So every body is lying on the surface called the friction. So this is for the surface here, and this is the body. So this is a mass. So mass is because of mass, this is the gravitational force. So Fg is equal to the mass multiplied the g. So in this case, Fg is a gravitational force. M is a mass. And g is a gravitation. So Fg is a gravitational force, M is a mass, and the g is a gravitation. So the mass is a directly fall on the surface. Surface called as frictional factor mu. So the frictional force can be calculated. The formula is mu multiplied the tower force, perpendicular force. So this is what is frictional force. You can calculate Fr. Fr is a frictional force. Frictional force is equal to perpendicular force multiply frictional coefficient. So perpendicular force multiply the friction coefficient of frictional force. So the frictional force Fr can be calculated. Perpendicular force is Fg multiplying friction coefficient mu. So Fg is equal to m into g into mu. So this is the frictional force. So if you screw this block by tension T, so to move the block, at least we need to overcome the frictional force. Okay. To move the block by pulling, it needs to overcome the frictional force. L. So therefore the L T must be equal to frictional force Fr, or that T must be equal to the mg into mu. So this is requirement to move the block. Requirement to move the block, tension T must be equal to the frictional force Fr or mg multiplied mu. So this is the important of the mg. So this is for the mg that we can calculate for the personnel. So the base is lying on the inclined plane. So in this case, this is the Fr is equal to the m into g downward. So this is the F is equal to m into g downward. This is the tension T. So this force can be divided into two components. One is the horizontal, one is the vertical. So this is angle theta T. So then we just this becomes the S into the sine theta, S into cos theta. This component is F into sine theta. So F cos theta got the frictional force Fr. Fr can be calculated F cos theta into mu. And so S sine theta is a power force. So in this case, this block is stationary. If the block position on inclined plane stationary. So what will you do is the hour force T is equal to all downward force. So downward force are F sin theta plus FR. So therefore the hour force T is equal to the F sin theta plus FR is equal to F cos theta into mu. So in this case, where F is equal to mg. So this is the equation to calculate the equation. The stationary. This block will not fall down and will not go up. So that all the outward force is P, all the downward force are frictional force, and the incline the gravitational force F sin theta. So that when you pull the pin, frictional force resist the moment. In the meantime, the gravitational force resist the outward movement. So that all the outward movements are T is equal to all the downward force F sin theta and the FR. So that we can write the equation F is equal to the T is equal to F sin theta plus the F cos theta into mu. So this is for the relationship of the friction for the inclined plane. So the 8 hour surface after having more than 290 meter from the when the brake was applied. So this is for the car. Okay, so this car we have to calculate the initial the velocity. The velocity we have to calculate. So the final velocity square is equal to the initial velocity square minus 2am. So this equation. The final velocity is 0. So we have to calculate v square is equal to v0 square minus 2am. So the v square final velocity is 0 square. v0 square we don't know. 2 into a calculation and s is 290. So we can calculate v0. So square root of so v0 square is equal to the 2a into 290. Okay, so the question therefore F is equal to the mu into the mg. Mu into mg. This is the question therefore. So in this case, you have to calculate the a. When you get the one you get the v0. So firstly, question therefore you need to calculate F is equal to mu into mg. So mu into mg can be calculated as this is the F is equal to mu is 0.6, m is 500, and g is 9.8. So by solving this one, you got the expression therefore F. So F is equal to 0.6 multiply 500 multiply 9.8. So there will be 2940 Newton. So and then you can calculate the acceleration. F is equal to ma. So the F is equal to 2940 minus 500 and the a. So a you can calculate 2940 divided by 500. So 2940 by 500 you can calculate the acceleration. So divided by the 500, so you got this 5.88 meter per second square. Okay, then so you can get the v0. So v0 square is equal to 2 into a into 290. So the 2 multiplied a is 5.88 and the 290. So then you can call the v0. So square root of 2 multiplied 5.88 into 290. So then you call the initial velocity v0. So 5.88 multiply 2 multiply 290. So 3410. So square root. So initial velocity is 58.3 meter per second. So this is for typical program involving the pressure. So this is for the mass of 3 kilogram. So F is 12 Newton. The 12 Newton is applied to it. So this is for the frictional force 12 Newton applied. So in this case, we have to calculate the maximum value of theta, maximum value of the block acceleration. So this means that this is the mass here. So mass is that this is the m into g. So downward and frictional force will be the mg into mu. So this is Fi is equal to mg into mu. So this force. This is our frictional force. And then acceleration. So in this case, FR is the two things because this tension T's are made of two components. This tension T is the angle theta here. This T you can divide to the fortunate, so this is TA and vertical is TY. So MG and the TY are opposite. So net force are 4 on this flow. Therefore, this is a net force. Fy net force is equal to, so this is what is mg downward minus ty outward. So this one we can write. So therefore we can calculate Fy net force is equal to mg. So mass is equal to 3 kilograms. G is 9.81. This is downward minus ty. So ty is we can calculate T is 5 theta. So this is the equation 1. Fy net is 3 into the 9.81 into T is 5 theta. And in this model is TH you can also calculate. T is T into cos theta. T is T into cos theta. So to move the thing, so TH is must be equal to the frictional force. So TH is equal to frictional force. So the TH we can calculate the T cos theta. Frictional force is equal to the Fy net multiply mu. So in this case TH is 12 Newton. 12 cos theta is equal to Fy net. Fy net is 3 into 9.81 minus T sin theta into mu. The mu value is we calculate 0.4. Okay, so this equation, so you get 5 divided by 12 divided by cos theta by 0.4. This is 3 multiplied 9.81. So 3 multiplied 9.81 is 29.43 minus 12 sin theta. Okay, so there you get write down. So then we get 30 cos theta is equal to 29.43 minus 12 sin theta. So then you get the angle theta from this equation. So then we get 12 sin theta plus 30 cos theta is 29.43. So 12 sin theta minus plus 30 cos theta is 29.43. So we write the equation sin theta and the cos theta. So sin theta is equal to 1 minus cos square theta, or cos theta is 1 minus sin square theta. So that's equation. So this becomes sin theta is equal to the 1 minus cos square theta. So then we substitute here 12 into 1 minus cos square theta plus 30 into cos theta equal to 29.43. So this equation we got, so angle theta can be the maximum. So you have to substitute the angle theta value. So how to use the angle theta value is, you substitute angle 0 to 90 degrees. Okay, so when you substitute the angle theta equal to 0, always you have in, so left hand side. The left side 12 into sin 0 plus 30 into cos 0. Is equal to the 29.43. So we put the angle theta 0. So then we get left hand side is we can calculate what you call it. You can calculate the 30. So it's equal to right hand side 29.43. So this is approximately equal. And therefore to make the maximum force, then you put the angle theta 0. So this is to get the maximum force. Maximum moment, theta must be 0. This equation. So we put the equation here, we can put any theta value. So by putting the theta is 0, so the left hand side is equal to right hand side, approximately equal to right hand side, and therefore to get the maximum moment, we can put the theta equal to 0. Friction, so moment and the friction. So this is force and acceleration, and I end it with a friction. So Next is isolated stretching and uniform motion, circular motion, acceleration. So then we will do next week. A 2 kilograms of cookie stain is separated at the 3 meter per second square in a direction shown by the A bar. So the fractional force in the surface, acceleration caused by the 3 forces in the force. So only F1 10 newton and F2 20 newtons are given. So we have to calculate the that force. So in this case, we can see the thing here. So this is the F2. F2, and this is acceleration A at the 50 degree. And this is for the F1. F1 is 30 degree. So in this case, we can have to add the all force. So there's acceleration means there will be the net force, net acceleration. So net acceleration is you can calculate so the F net is equal to mass multiply A. So this equation. So the mass is 2 kilograms. So this is 2 multiply A is the acceleration. Acceleration is given. So acceleration 3 meter per second to 3. This acceleration is at 50 degree. So this is the 3 cos theta, cos 50. So this is what is the 6 cos 50. So this is net acceleration. Okay, so we can calculate. So this is F net is equal to this holding the all is a positive, and therefore the right hand side. So this is for the F3. We assume that the F3 is here. F3 is a positive plus minus F1. F1 cos 30. So this is a negative. Is equal to 6 cos 50. So that we can see the F3. F3 is a minus F1. F1 is we already know. F1 is a magnitude of 10 newton. F2 is a 20 newton. F3 does not F2 does not include because of this is the perpendicular. Perpendicular F2 does not influence on the overall acceleration. So in this case, F1 is a 10. Cos 30 is a 0.86 equal to 6 cos 50. So from here you can get the F3. F3 is equal to 6 cos 50 plus 8.66. And you got the F3. So the next one is the gravitational force. So the I is the influence any particle about the earth surface. So this is the gravitational force. So this is the